In this lesson, we're going to be talking about intrusion detection. Intrusion detection is based on an examination of the packets as they either come through the network or come to a particular device. So in this case, we're talking about network intrusion detection. And so they are looking at messages passing over the network, and they're comparing those messages against particular signatures. Maybe if you're looking for a back orifice connection, or maybe a Zeus connection or something like that, you'd be looking for either a particular port or a particular packet signature. So intrusion detection is something that you would see pretty commonly in larger networks, and you have the ability to configure a lot of different rules to look for different things. Right here, what I'm actually running is a piece of software called Snort, and this is actually a web front end to Snort to look at rules. And so you've got the basic analysis and security engine, and this is actually a piece of software called Acid Base. I can take a look at the different alerts that came in today, and so I've got a number of alerts based on bad traffic, same source and destination. So this is the signature, and this is the ID. I can also look up more information about this particular signature on Snort or in BugTrack or CVE. We've got information about the specifics. So I've got a source address and a destination address, and then I've got the layered protocol. So if I click on the source address, it gives me some additional detail here. I've got a number of sensors. I've got occurrences as the source address for this particular IP address. So I've actually got 169,653 entries as the source address through this particular intrusion detection device. So I could check for port scans. And so actually what we've got here is an error. No file was specified in the port scan file variable. I'm going to go back home and see whether there's anything else. Let's take a look at the last source ports for TCP and see what we get. So we've got this one here, and it looks like the source port is 80. And I've got 663 occurrences going back to August 4th of last year. So I could look up the information at SANS about this particular alert and see what it has to say. Actually, what it's looking up is the port. And port 80, of course, is the web port. So this is a threat level of green, meaning it's pretty safe. So we've got several other ports here that we could end up looking up more information about. And again, you could look at SANS for information about the particular port. This is just a pretty basic interface to an intrusion detection system. And the thing about intrusion detection systems, again, is they're based on rules or signatures. You have to create a rule, which means you have to know what it is you're looking for. Without telling the IDS what you're looking for, it has no ability to know what's good or bad. You actually have to tell it. There's a pretty high potential for false positives here if the server is misconfigured, or if there's a rule that you probably don't want turned on based on the amount of traffic, because you're going to get a high level of alerts for it. So intrusion detection can actually take a lot of care and feeding just to be able to run effectively. And again, you can see there's an awful lot of information in this one, and not all of it is all that useful. A lot of it, frankly, is bogus. I can take a look at the listing here, and I've got this bad traffic, same source and destination. Well, this is a multicast address, and it's IGMP, so it's not actually bad messages per se, but for whatever reason, those IGMP messages have gotten caught by this IDS. So that's where it takes a lot of work to do the configuration for intrusion detection. And it also takes understanding the individual protocols so that you can actually write rules for the IDS. You have to know what the protocol headers and commands are so that you could write the rules and actually catch bad or malicious traffic. So intrusion detection is another way of doing network analysis at the protocol level.